Okay, so I do just want to go through these last two examples. So for integral test, determine if the given series is convergent or divergent. I want to start with the sum of natural log of n over n. Okay, and again, I just want to remark that this is not a geometric series. Okay, and if I try nth term test, I'm going to get a limit of 0, which means the test fails. Okay, something new to check, is it a p-series? Okay, is it a number over n to a power? And the answer is no, so it's not a p-series. Okay, so I am going to go ahead and try an integral test. Okay, so if you haven't already, I want you to go ahead and integral test this, pause, and come back when you're done. Okay, so the first thing I do for an integral test is to figure out the function that would correspond to my series, and that function is natural log of x over x. Okay, set up the corresponding integral. I'm going to want the integral from 1 to infinity of natural log of x over x dx. Okay, I need to substitute that infinite bound. And now I'm ready to integrate. Okay, if you look at your function now that you're trying to integrate natural log of x over x, it is a quotient, okay, which requires either to be simplified or a u sub. Okay, we're going to u sub this, but what I want you to do is I want you to do your u substitution exclusively on the outside. Okay, one of the things that we're talking about when we were doing our u subs is that we can't keep the bounds on our old integral on our new u sub integral. I have two issues now. I have new bounds and I have a limit out front, so I'd have to change both of those things if I wanted to do this, you know, as part of one single stream of consciousness. So we're going to do our u substitution exclusively on the outside. We are not going to change our bounds, and then we're going to come back to x. Okay, and that's what's really important for this. Okay, so we'll use that u is natural log of x, which means that du would be 1 over x dx. Okay, when I make the u substitution, the new integral would look like this. Okay, so I'd have the integral of u du, which would give me u squared over 2. Okay, once I've finished up with my u sub, I'm going to go back to my limit, I'm going to go back to my integral. So again, if you need to pause and do that, but I would get, when I plug back in, the limit as t approaches infinity of, instead of u squared over 2, it's natural log of x squared over 2, and I'm going to go from 1 to t, plug in upper bound minus lower bound, and I will have the limit as t approaches infinity of natural log t squared over 2 minus natural log of 1 squared over 2. This second term is just 0, but this first term, as t goes towards infinity, is going to approach infinity. This makes the integral divergent. If the integral diverges, then the series is also divergent. Okay, let's follow up with that next example. Okay, again, I want to decide if this is convergent or divergent, and I have the sum of n e to the negative n. Okay, so just to go through, I want to go and remark that this is not geometric. Okay, if I try an nth term test, and I take the limit as n goes towards infinity, I would have an infinity times an e to the negative infinity, crudely speaking, of course, which would be an infinity over e to the infinity, which if I do dominance or L'Hopital's, I will get a limit of 0, which means nth term test fails. Okay, is it a p-series? Is it a number over n to a power? No, it's not a p-series either. So my only other option right now is to do an integral test. So you're going to start your integral test by, and again, you know, try to work through it and then come back to the video if you haven't already worked through it. You start your integral test by writing a corresponding function, and that function would be, okay, once we have our function, which would be x e to the negative x, I'm going to write the corresponding integral for the integral test, which would be the integral from 1 to infinity of x e to the negative x dx. Okay, first I need to make this not improper. Okay, and then I need to go ahead and integrate this. All right, if I look at this function, it is a product and it is a composite, and I cannot simplify it. If I try a normal u sub is not going to work for me. I'm going to need to do integration by parts on this. Again, I would like for you to do that exclusively on the side, and then come back to the limit and come back to the bounds. Okay, so you can either use tables or you can use the long way. Okay, I'm going to do by parts the long way, because tables is a lot easier, so if you need to see something, I'm guessing it's this. So I'm going to let u equal x and dv be, I'm missing a dx there. That's better, so dv would be e to the negative x dx, okay, and then I need my du and my v, so du would be dx and v would be negative e to the negative x, okay. So I'm going to do my uv minus the integral of v du. Okay, and that would be my negative x e to the negative x plus the integral of e to the negative x dx. And if I integrate that, I get x e to the negative x minus e to the negative x. All right, so once I'm finished with my integration by parts, I'm going to go back to my limit and my bounds. All right, so I'm having a terrible time with this program to try to get this to look nicely for you guys, but if you go ahead and take the limit, we'll finish this limit up in class. You should come up with a convergent value to the integral, and therefore the series would also converge. But we'll finish this up in class tomorrow. But try to finish it up on your own, do upper minus lower, take your limits, try to evaluate those limits, look at them carefully, because your very first term when you take that limit is going to be a little tricky, but we'll go over it in class tomorrow.